This video is about boiling point. By the end of this video, you should understand what vapor pressure is, understand how vapor pressure relates to boiling point, and be able to explain why boiling point varies with atmospheric pressure. As we've seen before, temperature is a measure of average kinetic energy of all the particles in a system. Therefore, at any temperature, some molecules in a liquid will have enough energy to break free and join the gas phase. As the temperature rises, the fraction of molecules that have enough energy will increase, as shown in the diagram here. At a low temperature, very few of our particles have enough energy to enter the gas phase. At a higher temperature, more and more particles will have enough energy to escape the liquid phase and become a gas. The pressure exerted by these particles in the gas phase above the liquid is called the vapor pressure. This diagram shows us a particle view of vapor pressure. First, liquid ethanol is injected into an evacuated flask with zero pressure since it contains no particles. When the liquid enters the flask, some particles will join the gas phase. Eventually, more and more will join the gas phase, and some will start to rejoin the liquid phase until equilibrium is established. The pressure of the gas phase at equilibrium is called the equilibrium vapor pressure, or just the vapor pressure. Here's another look at this same concept. Again, we begin with vaporization, then we get a bit more condensation until the rates of vaporization and condensation become equal. At this point, we've reached equilibrium. The pressure of the vapor phase, then, is our vapor pressure. Liquids with a high vapor pressure are said to be highly volatile, meaning they evaporate readily from an open dish. Weak intermolecular forces are correlated with high volatility and high vapor pressure. Strong intermolecular forces result in low volatility and low vapor pressure. Vapor pressure increases significantly with temperature because more particles at a higher temperature will have enough energy to join the vapor phase. It's also important to note that while we usually talk about the vapor pressure of liquids, even solids have vapor pressures. They're just quite low. So what does this have to do with boiling point? Previously, we've talked about boiling point as if it's an absolute temperature and only dependent on temperature. Let's define normal boiling point and normal melting point. Normal melting point refers to the temperature at which the solid and the liquid have the same vapor pressure under conditions where the total pressure is 1 atm. The normal boiling point is the temperature at which the vapor pressure of the liquid is exactly 1 atm. Of course, sometimes liquids can disobey these points. Supercooling refers to the condition where a liquid is cooled below its melting point but remains a solid. Superheating refers to a liquid that is heated above its boiling point but remains a liquid. Both of these situations are very unstable and won't last long. They're also difficult to achieve. So let's focus in on boiling point with this new idea of normal boiling point in mind. When we say boiling point, what we actually mean is the temperature at which the vapor pressure of the liquid is equal to the atmospheric pressure. Normal boiling point is the temperature at which the vapor pressure of the liquid is 1 atm, since 1 atm is the standard for atmospheric pressure. However, when atmospheric pressure varies from 1 atm, the boiling point will also vary. Consider the diagram shown here. Here we have liquid water in the bottom and water vapor at the top. You can think of the atmospheric pressure like a lid, keeping the water in the liquid phase. Here we've represented atmospheric pressure with the red arrow and vapor pressure with the blue arrow. When the atmospheric pressure is greater than the vapor pressure, the liquid will not boil. However, as soon as the vapor pressure of the liquid, represented in blue, becomes equal to or greater than the atmospheric pressure, the liquid will boil. This explains why water boils at different temperatures at different altitudes. As you may know, atmospheric pressure decreases greatly with increasing altitude. Therefore, water will boil at a lower temperature at higher altitudes, since the vapor pressure does not need to be as high to equal the atmospheric pressure. Now let's consider vapor pressure and boiling point for a few different liquids. Here we see diethyl ether with very weak intermolecular forces versus water and ethylene glycol with very strong intermolecular forces. Notice that each of their normal boiling points occurs at 1 atm or 760 torr. However, the temperature at which the vapor pressure of each liquid becomes equal to this pressure value of the atmosphere is different for each liquid, depending on its intermolecular forces. You have to heat water up more for its vapor pressure to achieve the atmospheric pressure than you do diethyl ether. That brings us to the end of this video. Let's review our goals. First, we looked at what vapor pressure is, then we looked at how vapor pressure relates to boiling point, and finally we learned to explain why boiling point varies with atmospheric pressure.